Welcome to my Mastering VMware vSphere 6. This chapter, we're working with Chapter 9, Creating and Managing VMs. So, the nice thing here with a VM is it's hardware independent. It does its own collection of virtual hardware resources. So, inside a virtual machine or a VM, typically you'll have a VNX BIOS, you'll have an Intel based motherboard, the appropriate PCI ACH controller, an IDE drive, an optical drive, the appropriate LSI, logical parallel SCSI controller cards or SAS controller cards, an AMD or Intel CPU depending on the physical hardware, and an Intel E1000, E1000E, or AMD's PCNet NIC, along with a standard VGA adapter card. This is the basic hardware. So the important thing to notice here is, again, it's hardware independent. So depending on if you're putting on a Linux machine or a Windows machine or Mac or any variation, the virtual machine is going to run on top of anything. Because again, it's hardware independent. It's all software, and this is what the standard settings are. So let's talk about maximums. In vSphere 6, we have a few maximums that we have to adhere to. We are allowed a maximum of 128 virtual CPUs per VM, 4 terabytes of RAM, 4 SCSI adapters, 60 SCSI targets, 62 terabytes of virtual disk space, 4 SATA adapters, 30 SATA devices, 10 network cards, and a maximum of 512 video RAM that's dedicated to it. This is kind of important because they like to test you on the maximums. When I did my VCP 5.5 and 6, same thing. We powered on one VM. It had 130 virtual CPUs. Through this error, what could cause it? If you didn't know the maximums, you would not be able to answer the appropriate questions. So, do keep that in mind and make sure you know the maximums. So, the virtual machines from the outside. There are specific types of files that you need to be aware of. The two big file types are a .vmx and a .vmdk. VMX is the configuration file. VMDK is the hard drive file, which we have discussed in previous slides. Again, the VMDK is a virtual disk, and the VMX is actually the configuration for the virtual machine itself. You can actually open it in Notepad, and you can edit it in Notepad as well. The VMX file, because it is basically a text document with the appropriate .vmx file extension, this actually defines the hardware. The number of processors, the amount of memory, the NICs, MAC address, connection, the numbers, the names, all of the appropriate locations of all the virtual drives and virtual resources. Everything dealing with your VM is typically found in the VMX configuration file. What gets kind of interesting is the different types of VM hardware versions, because depending on the hardware version, you may again have different types of CPUs allowed, different amounts of CPUs allowed. So make sure you understand what hardware version you're working with and what hardware version your vSphere is able to work with. For example, I did a upgrade to a hardware version 10 VM, and I had a vSphere 5 environment. Couldn't use vSphere, or you couldn't use hardware version 10 in that. It would not work. Hardware version 10, the second you upgrade to it, you cannot downgrade. Second, it starts controlling what you can and can't do with it. For example, hardware version 10 gets very particular about how you edit it, and that's normally only done through the web interface, through vCenter. So some of these hardware versions do have some specific situations that you want to be aware of. So you want to make sure to choose the right values for the number of virtual processors, memory, NICs, and all of the appropriate settings for your VM. Because, it's going to be based off of your needs. It's going to be based off of your situation. Oversizing and undersizing does lead to performance issues. You can balloon, meaning you can actually issue more resources than what you have physically available. In our lab environment, we have 32 gigs of memory in our physical PCs. Well, we allot so much memory to each machine, and if every machine is using 100% of its memory, we've actually over allocated, I think, 4 gigs, because in the allocation process, we've allocated 36 gigs of total memory, even though realistically we only have available 32 gigs of physical memory. So you end up with having to understand how to provision your resources to your VMs. Because again, we're talking about what resources that you want it to be maximum using. At startup, they may use a large portion of it, but on the everyday, every process type, how much resource are they really using? So keep that in mind when you're dealing with the provisioning. You don't want to underutilize or over provision server leads because again, this deals with over allocation, which could lead to poorer performance if done incorrectly. Use a capacity planner to help plan for this. Normally, I'll over allocate 10 to 15% of my resources, even if I know that I'm going to fall short of that. I try to just stay where, just in case a critical situation does occur and the physical machine restarts, I'm able to recover all VMs without any real major issues. We've already done several installs of our guest operating system. We've done it through both the data store ISO and through our host device. Well, you can also do it through a network or PXE install, pre-installation environment. Because again, how we get the VM created isn't super important. There's multiple avenues. We've also worked with the console, and that's how we would interact with our VM as if it was a physical machine instead of a virtual machine. That's what that console allows us. Basically, it's like our monitor. All of the keystrokes and mouse clicks will be directed to that VM for the most part. Sometimes, having nested VMs, you end up with some weird situations where mouse clicks don't actually don't properly get redirected to the appropriate VM. So that's been a concern which we've already encountered in our lab, which we discussed in our lab videos. So, an important part when we're talking about vCenter or virtual machines or any time that we've had a VM capture our mouse and keyboard, how do we get our mouse and keyboard back? You can actually control Alt, and that will release it from whatever VM session that it's currently active. So VMware Tools is not installed by default, but this is extremely important to install. It optimizes things like our NIC drivers, our SCSI drivers. It allows for our VM heartbeat. It improves drastically video and mouse capability. It also allows for API access to VMware utilities. Also, it allows access to our clipboard so we can copy to and from. So let's talk about how we create and manage these. We can add or register a pre-existing VM in vCenter by right-clicking on any type of data store and we could register it. Or you can browse to the VMX file, double-click on it, and that will add to the inventory of the machines. When you go to actually add the VMX file, it will go through an import wizard. Where do you want to save it? What host do you want to save it on? All of that good things. We have power state management for our VMs. We have hard power off, and we have a soft power off. So when it says power on, power off, suspend, or reset, those are hard, meaning that's like holding the power button down. As opposed to shut down guest OS, that's more of a clicking on start and telling it to shut down. Both have their uses. For example, when your VM becomes unresponsive, power off forces it to power off. Restart guest OS will send a soft shutdown command, but if it doesn't actually respond, then it's really hard to get the machine to power off safely. So again, shutdown guest OS only works if VMware Tools is installed. And again, it invokes an orderly shutdown of that guest operating system. Restart guest OS is just like shutdown guest command, but this requires VMware Tools, and this initiates the reboot, not shutdown. We can also modify our VMs by removing them. Removing them doesn't remove them from the storage and will allow us to remove it from the inventory, which we can always re-add later. Basically, it's a way to hide it from vCenter. Deleting VMs will actually delete it from the storage. And that should delete both the VMX and the VMDK files. These are not reversible, so you want to make sure you have the appropriate backups. And normally for this option, the VM has to be completely powered off. We can always change hardware. Changing of hardware typically requires the VM to be powered off. However, in our lab, we're going to see that we can actually turn on hot swappable items so that we can add them while they're on. Like, for example, adding a processor or adding memory while the VM is on. Totally possible, but you have to enable certain features for this to take effect. Any type of hardware that is natively hot swappable should also be able to be modified while the VM is running. For example, SCSI and SATA and network adapters should be able to be added when the machine is on. Same thing with USB type devices. Some guest operating systems, again, do support the appropriate CPU and RAM when features are enabled in vCenter. Snapshots are a way to do soft backups, and guests can be queued or sequenced so that backups happen at regular intervals. Admins can revert to their pre-snapshot states just in case something happened. Basically, this allows you to take a snapshot and preserve admin or preserve changes so that if the admin wants to commit the changes, they can always go back and remove the snapshot and then no longer being able to revert to a previous state. VM snapshot technology does consume minimum space while still reverting to a previous snapshot by allocating only enough space to store the changes rather than a full copy. So it doesn't make a complete copy. It only makes a copy of the changes. Snapshots are one way of doing backups. This is different from replication. This is just a way to do a snapshot in time. If you want a full copy, I would make a clone that's full. Requires more space, but does allow you to recover if the entire VM gets corrupted. That's actually it for this chapter. I want to thank you.